It started with a whisper, a rumor that drifted through the quiet corridors of late-night labs and online forums, barely more than a question at first. That whisper soon became a roar. NASA reveals image of alien structures on Proxima B. The world was captivated, headlines blazed across screens, and social media exploded with speculation and excitement. Suddenly, the universe felt a little less lonely. For a moment, it seemed as if the vast emptiness between stars had been bridged by the possibility of neighbors, intelligent life perhaps just 4 light-years away. Could it be true? Had we finally found proof that we are not alone, etched in the form of glowing cities on a planet orbiting our nearest stellar neighbor? The idea was intoxicating, igniting imaginations everywhere. This idea taps into our deepest questions about our place in the cosmos. Are we unique, or is life a common thread woven throughout the universe? We are explorers by nature, always looking beyond the horizon, now to the stars. Our curiosity has driven us across oceans, over mountains, and now into the depths of space. The search for extraterrestrial life is more than science, it's a quest for connection and meaning. It's about understanding whether our story is singular or part of a much grander narrative. But with excitement comes the need for clarity. Sensational headlines can spark hope, but they can also cloud judgment. In our rush to embrace the extraordinary, we must also engage our intellect. Science demands skepticism, careful analysis, and a willingness to question even our most cherished hopes. The story of Proxima B is not a finished discovery but an ongoing investigation. Each new observation brings more questions, and every answer leads to new mysteries. Every clue must be carefully examined. The thrill of the chase is real, but we must not mistake hope for truth. The scientific process is slow, deliberate, and sometimes frustrating, but it is the only way to separate fact from fiction. So let's peel back the layers of the viral headline and look at the science behind the spectacle. What do we really know about Proxima B, and what remains in the realm of speculation? The cosmos does not need our embellishment to be magnificent, its reality is wonder enough. As we search for answers, let's remember that the universe, in all its mystery, is already more astonishing than any fiction we could invent. Before we talk about cities on other worlds, let's define what those worlds actually are. When we gaze up at the night sky, we see countless stars, but for most of human history, we had no idea if any of those distant suns had planets of their own. For centuries, the only planets we knew were the ones orbiting our own sun: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. Our solar system was the entire known universe of planets, but the universe is vast. With billions of stars in our galaxy alone, astronomers long suspected that many of those stars must have their own planetary systems. These distant worlds are called exoplanets, planets that orbit stars beyond our sun. For generations, exoplanets were the stuff of imagination and speculation, appearing in science fiction stories and fueling dreams of other Earths. Everything changed in the 1990s when astronomers developed ingenious techniques to detect exoplanets. Instead of seeing the planets directly, they looked for subtle clues, tiny changes in the light or motion of distant stars. The transit method, for example, searches for minuscule dips in a star's brightness as a planet crosses in front of it, blocking a fraction of the light. This method has revealed thousands of new worlds. Another powerful technique, the radial velocity method, detects the gentle wobble of a star caused by the gravitational pull of an orbiting planet. This wobble can be measured with incredible precision. Using these methods, astronomers discovered Proxima B, a planet orbiting the closest star to our sun, Proxima Centauri, a breakthrough that brought exoplanets into the spotlight. Thanks to these revolutionary techniques, we've confirmed over 5,500 exoplanets in just a few decades, and the number keeps growing every year. Among these discoveries are hot Jupiters, giant planets orbiting scorchingly close to their stars, icy super-Earths, and mysterious water worlds that challenge our understanding of what planets can be. We now know that planets are not rare or unusual. In fact, they're everywhere. Planets are not the exception, they're the rule. Nearly every star in the night sky likely has at least one planet, and many have entire families of worlds orbiting them. Our solar system is just one household in a vast galactic neighborhood surrounded by countless other planetary systems waiting to be explored. Let's return to that viral image of Proxima B. You might remember seeing it online, a breathtaking vision of an alien world, complete with dramatic lighting and mysterious structures. It's the kind of image that instantly sparks our imagination and makes us wonder what's really out there. It shows a rocky landscape under a red sun, with what looks like an alien metropolis sprawling across the horizon. The colors are vivid, the details are striking, and the scene feels almost real, like a snapshot from a distant planet. But here's the truth, it's not a photograph. It's an artist's concept, a creative interpretation of what Proxima B might look like based on scientific clues. These illustrations translate complex data, numbers, graphs, and spectra, into visuals we can connect with emotionally. They help us picture the unknown, turning abstract science into something tangible. Think of it like a police sketch. It's not a photo of the suspect, but a visualization based on the best available information. It's a tool to help us imagine, not a literal record. Scientists provide the raw data, details like mass, size, distance from its star, and possible atmosphere. Artists then use this information, along with their creativity, to build a plausible scene that fits what we know, while filling in the gaps with educated guesses. These images are meant to educate and inspire, not deceive. They're designed to make science accessible, to spark curiosity in students, and to help the public visualize worlds beyond our own. In this way, they bridge the gap between technical data and public imagination, making distant exoplanets feel a little closer to home. Sometimes artists add speculative elements, like alien cities or unusual landscapes, to capture attention and fuel wonder. These creative touches are meant to engage, not mislead. But it's important to remember, we have found no evidence of techno-signatures, alien structures, or advanced civilizations on Proxima B or any exoplanet so far. The science is still unfolding. So, appreciate these images as a blend of science and imagination, a collaboration between data and dreams. Let them fuel your curiosity, but always ask where the data ends and artistry begins. That's where the real adventure starts. The reality of the science is compelling enough, and as our tools improve, the line between art and artifact may one day blur in ways we can only imagine. Creating an artist's concept of an exoplanet is a collaboration between science and art. For Proxima B, we know it's a rocky planet, slightly more massive than Earth, orbiting a red dwarf star. Its sky would be dim and red, shaping the artist's palette. Proxima B is likely tidally locked, with one side in perpetual day, the other in endless night. The most interesting region is the twilight zone between extremes, where liquid water might exist. Artists use these scientific clues to build a plausible scene, consulting with researchers for accuracy. They might add clouds, craters, or mountains, all based on informed speculation. Every detail is chosen to reflect our best understanding of planetary science. The final image is a visual hypothesis, a way to invite the public into the journey of exploration. It's not a snapshot, but our best guess, grounded in science. What do we actually know about Proxima B? It's the closest exoplanet to Earth, just 4.24 light-years away, a cosmic neighbor. Discovered in 2016 via the radial velocity method, it's a super-Earth, likely rocky. Its orbit places it in the habitable zone where liquid water could exist. This doesn't guarantee life, but it means the basic conditions might be present. However, Proxima B's parent star is a red dwarf, cooler and dimmer than our Sun, but much more volatile. To stay warm, Proxima B orbits very close, making it tidally locked, and that's just the start of its challenges. The idea of a habitable world next door is romantic, but reality is harsher. Proxima Centauri unleashes powerful stellar flares, bombarding Proxima B with intense radiation. This could strip away any atmosphere, leaving the planet barren. We have no evidence Proxima B even has an atmosphere. If it does, the tidally locked nature means one side bakes while the other freezes. Life might only survive in the narrow twilight band, facing extreme winds and temperature swings. Still, the universe is creative. Maybe life could exist underground or in a global ocean. Or perhaps a thick atmosphere and magnetic field could offer protection. We simply don't know. Proxima B reminds us that habitable zone is just a starting point. Habitability is far more complex. If we can't photograph Proxima B's surface, how do we learn about it? Enter the James Webb Space Telescope, an infrared observatory perfect for studying exoplanets. Its main tool is transit spectroscopy, analyzing starlight that passes through a planet's atmosphere during a transit. Different molecules absorb specific wavelengths, revealing atmospheric composition. But Proxima B doesn't transit its star from our viewpoint, so JWST can't use this method. This is a major challenge for astronomers. That's why direct imaging, actually taking a picture of the planet, is the holy grail. Next-generation ground-based telescopes like the Giant Magellan and European Extremely Large Telescope aim to do just that. Using giant mirrors and adaptive optics, they'll try to separate the planet's faint light from its star. If successful, they could analyze Proxima B's light for biosignatures, chemical hints of life. The search continues. Proxima B grabs headlines, but it's just one of thousands of exoplanets. Each new discovery expands our understanding of what planets can be. The TRAPPIST-1 system, for example, has 7 rocky Earth-sized planets, 3 in the habitable zone. Because they transit their star, JWST can study their atmospheres in detail. We found water worlds, super-Earths, and even diamond planets. This diversity shows that our solar system is just one arrangement among many. Studying these worlds refines our models of planetary science. The search for life is about understanding the full range of planetary possibilities. Proxima B is just the beginning. No, there's no confirmed photo of alien cities on Proxima B. The viral image was art, not evidence. But our exploration of this world has only just begun. We're at the dawn of studying distant planets, and Proxima B remains a compelling target. The real story is a grand adventure unfolding now. When you see a sensational headline, question it. Ask if it's based on data or speculation. The scientific method is our best tool for separating wishful thinking from reality. The search for life beyond Earth is profound, requiring patience, ingenuity, and global collaboration. We must be comfortable with uncertainty. Some answers may be decades away. The journey itself is the reward. So keep looking up, keep asking questions, and share real science. The universe may not be filled with life, but it's our privilege to search. The cosmos awaits.